So now that we've worked with some searching and sorting in arrays, let's do the same thing with vectors. So over here we have a vector of strings, and the strings are names. And of course we don't have to declare a size of the vector because it's automatically adjusted. We have to include vector library, and you see that we have three functions over here. Before we can do our search, we have to sort the vector, and as part of that sorting process we may have to swap two names to get them in the proper order. Notice over here that again we're not adding the size because we don't have to do that for the vector. Over here, once we have sorted the vector, then we don't want it to change anymore, so we just use the constant keyword over here when we send it to the binary search, because we just want to find it but not do anything with it. Over here we're just passing everything by reference, including the two strings over here in the swap function. We want to get two strings back again in the proper order, of course. This string over here is the string that we're looking for. So in the main function we have to define what we want to look for. We want to find where we can find it, and once we have one search value found or not found, we may want to search again. So we're just going to build in another loop here. Okay, so over here we have a string vector of names, and the first thing we're going to do is just show the unsorted vector. Then we're going to sort it with the selection sort. Then we're going to show the sorted one to show you that the sort actually works. And then over here we can do a do while loop to search names inside that vector of names. So we ask the user what is the name that you want to look for. We use the get line because sometimes we have spaces in names. And then we refer to the binary search where we send it the names vector and the name that we're looking for, and we get the position back. Now if we don't find it, we send the value -1 back. So if we get that back, if we don't get a -1 position back, then we say, okay, hey, we found it at this particular position. Otherwise, if the position is -1, then we get the message that the name was not found, and then we want to search again for another name, yes or no, give the answer, and make sure that you take out the return character over here. Now you also see here the function toLower, and this is basically makes it a little bit easier to work with the user answer. You don't have to specify or search again is equal to the uppercase Y. You just turn everything into a lowercase and then compare it with the lowercase y. In the swap function, it's the same again as before. Now over here we get a vector, and again we don't have to specify the size of the vector because that's built into the vector library. and instead of array we just call it v, and you see that we pass it by reference here. Then for the selection sort over here, we start at the beginning, we go up to the end -1, and going to the right over here we set the minimum index at the start over here for the sorted area on the left. Then over here the lowest value that we stand all the way to the left, and then we're going to go through whatever is left towards the right, which is the unsorted area. And then if we find that we have another value that we find that's less than the minimum that we have so far, then we say, okay, this is now the new minimum value and this is where we found it. And then when you get all the way to the right over here, you have a new minimum value, and if the minimum value and the start value that you look at, if they're out of order, then you call your swap function. So that gives you the sorted vector. And then over here in the binary search, we start by defining the first vector element and the last vector element. We need to know how we can calculate the middle position, and then over here we set the position at -1, indicating that we have not found it yet, and also a Boolean value to indicate the same. So over here we're going to run a while loop, and it's going to stop when we find it. When not found becomes false, and it continues while we have not had the minimum and the maximum value of the search area that we still have left, where they become the same position or overlap. So with the binary search we first find the middle, and then we see if that particular position is the string that we look for. This is the search string. If that's the case, then we say, hey, we found it over here and we find it over here, and when we get back over here to this loop, then not found becomes false and we just stop the while loop. If that's not the case, then we see if we need to look at the lower half, or if we need to look in the upper half. If it's in the lower half, then we just go up to the middle -1. And if it's in the upper half, then we say, okay, for the new search area over here, we're just going to go a little bit to the right from the middle that we found, and that's going to be the first element of the new range that we're going to be looking at. So let's run this here, and let's give it a little bit more space. Unsorted names over here, and then after sorting we show the sorted area over here, and I'm going to give a name to search for. Let's do Abernethy. Better not make any typos. And you find it at position 1, so index 1. Yeah, we want to do another one. Let's do Wilson. We find it at position 11 over here, and then if we would go to the previous one, Smith, that should be number 10, and indeed we find it over there. And let's say that we want to find Beckering, and we say, oh, not found. Okay, so Let's fix that and put my name in that vector. Not forget my comma. And let's run this again. So let's give it some space again. Unsorted has my name in it. Over here it's sorted and it's a little bit more towards the beginning. And then if we want to search for my name, then of course we find it over here. So good. So you can do that searching and sorting with arrays. You can also do it with vectors.